Hey there, Algebra half. Lesson 87 reminds me of lesson 84. Why? Because that one was called Properties of Equality. Well, this one's called Properties of Algebra, and it just means, okay, similar words and properties and concepts just for numbers. It doesn't need to be for an equation, though it usually has to do with equations. Let's ignore this T here. Commutative property is a familiar one. We've used it with equality. It works just for numbers in general, meaning that if I have 2 and it's being added to 5, it's the same as if I'm adding 5 to the number 2. There are operations that are purely commutative. Addition and multiplication being the properties we're referring to. You change the orders of the numbers, it doesn't change the product or the sum. 5 times 2 is still 10. Okay? That's commutative. And we want to know these words simply because, the book or the test oftentimes will say, like, okay, 2 plus 5 is the same as 5 plus 2. What's the word we use for that property? You got to be able to put in commutative. It's worth an entire test point, So this isn't just chump change types of things. This is things you need to know in high school to feel like you've heard them before, maybe even call them to memory. If we have a whole list of numbers like 2 plus 3 plus 4 plus 6, 2 or more numbers added, or if they were being multiplied, it would be the same thing. Let's show it as 2 times 3 times 4 times, because these are commutative and you can kind of flop them around. You'll end up with the same final results. That just means that we can use grouping symbols and associate two numbers, associative. Any two of them first, it's not going to matter. I can pick these two, or I could have picked to associate the very first two, or I could associate these last two, and then that means I'm going to solve for 4 plus 6 first, and then add the 2 plus 3 to get 15. No matter how I did that, it would have come out the same, right? Or over here, I can associate these, or I could associate 3 and 4, or I could associate 4 and 6. 6 times 24, it's all going to be the same, kind of why factor trees work. We can go in any order because these are commutative properties, meaning we can associate any two together like that with grouping symbols. Reflexive property is going to mean the most obvious thing, that A equals A, that a number, its value is equal to itself. It's reflexive, refers back to itself, okay? Simple enough. Symmetric property means that we can change the order of an equation. So if you want to set up something, you end up with like 10 equals x. Generally, the book wants that variable not on the right side, but instead to put it on the right side. So x equals 10, right? We like to put that on the left, and that's okay. The reflexive property says you can do that. Totally legal according to the rules of algebra. So A equals B or B equals A. Symmetry, right? It's symmetric. Associative. Commutative. Finally, my favorite, transitive property. We talked about transitive verbs in English. It's the same word. It sort of, I guess, kind of reminds me of it, but it talks about two things equaling the same thing, therefore they equal each other. If Dave and Sherry are the same age, and Sherry and Brooke are the same age, it means Dave and Brooke are the same age. We can show this by showing if A, goodness gracious, if A equals B, and B equals C, well then what do you think's true? It means A equals C, right? And that comes really in handy for like those meat math problems about ages, right? When like the book said, if this guy's the same age as this girl, and that girl's the same age as some other person, then that original guy, therefore, by this rule, transitive property is the same age as that other guy. So we can use that for relationships to solve things as well. Now, what if we said, use two of these properties now, commutative and associative, let's use those first two, remember how those work, to simplify. And in this case, simplify 5 times 25 times 20 equals 4. Okay? We notice that, it might be easier to solve 5 times 4 than it would be 5 times 20 or 5 times 25, because I know 5 times 4, it's 20. So let's put 5, using the commutative property, 5 times 4 is 20. What do I still have left over? I've got the 25 and the 20. Well, 20 times 20, let's associate those together. That's easy, because 2 times 2 is 4, and I got 2 zeros, so it's 400. Now, I just have this 25 left. You just can't lose track of things. So then we just use 400 times 25, and we're going to get 10,000, because 4 times 25 is 100, and add your zeros. For the practice problem, or no, that was the practice problem, so you're not going to have any practice problems. But the example 87.1 does a similar, you can read what they say for the solution. They're adding things together, and it's great for mental math. Put your 87 with your 13, then do the rest of the addition, because 3 plus 7 gets us to 90, gets us up to an even 100. That's really nice to use. And then put your 49 and 51 together, it's another 100. It's not always going to work out that way, but this is something we naturally just do in life, because 49 plus 51 is easier than the 51 plus 87. I mean, you could do it, but let's put our hundreds together and then put that together for a final 200, right? So let me know if you had any questions on these. Maybe write the names of these properties in your notes under lesson 87, properties of algebra, and keep working hard. Show me that in your problem set, no practice problems.